Many of the engineers investigating the Champlain Towers South condominium collapse in Miami have been shifting the focus of their attention to three particular columns in the pool deck. So today I have some new visuals that will help us understand everything better. We also have new engineering analysis that were presented to us by two different engineers. To help us understand this better, I want to show you this overlay that I created for us that will help us visualize better what's happening between these three columns and the pool deck. And I want to show you some anomalies that I also found. All of this here will serve to help us understand better what these new structural engineers are going to show us today. All right, so as we all know, this is page 162 of 336 of the original 1979 floor plan. And you can just see the general outline of the building up here. And then down here is where like the planters are. So what I want to do is create this overlay that helps us visualize better what's going on. And we're going to focus our efforts down here on the whole pool deck area. So you can see what I did here is I colorized where all of these beam A's are on the floor plan, which go underneath all of those planters. And then here's L11.1, and here's M11.1, and here's K13.1. These are the three most suspect columns for the collapse of the Champlain Towers South in Miami. And then now I want you to pay special attention to right here on this left-hand side on column K, going right through K13.1, is that step down. And it extends from the top here, from this BMA at the top, all the way down to the south wall of the property. And remember, 87 Park is the condo next door, would be right over in here. So here's our south wall. And then note, I want you to pay special attention to this BMA right here, because it's going to disappear along with this in a minute, and we want to know why. Okay, so now here's where it gets fancy. I was able to take this Google satellite map here and superimpose it over everything. So now we have a much better idea of where all of these are. And so remember, pay attention to where K13.1 is. He is right over here in the middle of this planter, right next to that trash can. This here is where L11.1 and M11.1 are. These are both inside those planters there. And of course, this right here is Sarah Nair's unit number 111 on the first floor. So this was her patio right here. That's her furniture. So that gives us a better idea. That's what collapsed in, the ramp. This is the roadway through the garage in here, the main driveway through the garage. So the ramp starts right here, right under Sarah's condominium unit, and it goes right up to the north. What we can do here is adjust the transparency of the satellite image to step back and forth between the floor plan and understanding what was really going on that pool deck. So this is so crucial in giving us that understanding of what was going on in this area, because this is the area where most of us think it happened. I was initially focused on M11.1 and L11.1, and others have been bringing up K13.1 as well. So either way, you know, we're within 20 feet of each other. We really have it narrowed down to this area of the pool deck. I know a lot of people think that the problem started here at the south wall and that it just somehow collapsed here, but there really hasn't been any visual evidence that makes me get off the fence, literally, on this one and say, hey, I think that's where it might have happened. I just don't see it. Yes, I know it wasn't a perfect connection there at that south wall with the slab, but I think that that wasn't the cause. I think that the slab came off of the south wall as a result of the actual collapse of the deck. I think that south wall connection was the victim, not the criminal. Okay, and then see what his beam is here. He's supposed to go here. Something strange happened because these floor plans were done in 1979, and yet take a look at this here. This is the 1979 plans. It says it right here at the bottom right, August 22nd, 1979. However, there's a revision note over here from January 17th, 1980. And what does that say? Let's zoom in a little closer. And it says right there in the revisions, change of column type. Now, I didn't really look in too many detail to try to determine which columns had changed, but it goes to show that something happened here in a few months later in 1980. And you can see it says right here 1980 here, but yet these are the 1979 floor plans. So there was some type of a change made here. And so as we zoom into what change was done here, I want you to take a look at something here. Here's the same, all of these BMAs here are still present. However, look what happened here. We lost that step down here that went all the way down to the south wall. That's gone now, completely gone, right along that K column line. See that? That's K13.1 right there. And we also lost that beam that was supposed to be right here. What happened to that beam? And then when we do the overlay, you can sort of see here. So I'm going to show you, here's after, And I'm just going to show you here the before and after. I'm going to go back and forward here. Before and after. Before and after. And you can see they took that out. So my question is, why did they take this out? You know, now Josh Porter had pointed this out, I think back in like August of 2021 on one of his earlier videos on the Champlain Towers condo collapse. If you haven't been to Josh's channel, you should check his channel out as well. He has a lot of good, useful content covering this as well. Why did they remove that step down? And why did they remove that beam A? Because remember, folks, by eliminating that step down, you now lose that integrated beam, that huge beam that you would have had as part of that step down, as you can see here in the design. Could it be they thought they were going to get rid of the planters, and maybe somebody forgot to actually get rid of the planters along that west side of the pool? I don't think we'll ever know why that was done. Was it an oversight? I don't know. Now, there's something else that I wanted to show you here on the pool deck that's really been bothering me for a while, and I really wanted to show you this for a long time. So check this out. Okay, so here is page 33 out of 336 on the floor plans. And this here is the basement level dimension. So this is the clearest drawing I could find that shows us the spacing of all of the columns. And I want you to take a look at something here. I know some of you out there are probably going to say, come on, Jeff, you're just being suspicious for no reason.
Why? You've got nothing to be suspicious about.
I get paid to be suspicious when I got nothing to be suspicious about.
Take a look at this spacing. Do you see how the spacing between all of the columns here is pretty much roughly square, and it's roughly the same distance. Some of them are 19 feet apart, as you can see here. Some are 22 feet apart, some are 21. But they're all kind of within that same kind of spacing. But if you look down here at K13.1, I want to zoom into this area close to it here to show you what I'm talking about. Look at the distance between 13.1 and this one, and this one, and this one. You see how they're all kind of very similar, right? However, look at the distance between K13.1 right here and this last row of columns right here. That's a much longer distance. Those are much bigger tributaries. See that? That distance there and that distance there is much bigger than this distance here. And then in a similar manner, this entire last row here of these columns is 26 feet from the wall. And so my question to you is, what do you think? Do you think that's too much of a distance? Is that too big of a tributary there in order to guarantee any kind of safety there for your slab and prevent all that slab deflection that we want to avoid? Now, for those of you who are uncertain, let me show you what the tributaries are. Yeah, so constructor.org has this perfect diagram for it. When you have a bunch of columns together here, the tributary is this area that extends from your current column to half the distance of the other one. Just think when you're playing football, half the distance to the goal line. But here's what you got. Think of it as this area that just covers the halfway point, okay? And so the weakest point is going to be right here in the middle. That's where the most deflection is going to be, on either side, and then on the top and on the bottom. I drew these tributaries here, and you can see how the ones along the bottom are bigger, and the ones around K13.1 are bigger than all of the other ones, like around L11.1 and M11.1. So this begs the question then, does this cause a problem for us? Is this something else that the engineers need to be looking at? I think this does indeed create a problem for that specific area of the pool deck. And then here, when we look at page 307 of the floor plans, which is the pile cap plan, this shows it much more obvious with all the clutter out of the way. You can see the difference here from K13.1 down to this next one, and then from this one down to the south wall. Compare these distances here to these much smaller distances between all of the other columns. Let's take a better look at the spacing between these columns. This here is the collapse the morning after it happened, and you can see the firemen and the early responders here are searching the rubble pile. But this right here is column K13.1. You can see it poking up, and there's the trash can. Now remember, this entire deck was actually up higher. It was sitting on top of all of these columns that you see here. See the white here turning into the orange? There's where the floor slab was. So the entire floor has sunken down here. It looks like about 6 feet or so, because it landed on top of the cars below it. But again, this illustrates the spacing that I was telling you about between K13.1 over here and way over here to this column here. And from this aerial vantage point here, you can really see the huge distances. So look here between K13.1 right here and L13.1 over here. Now look at the distance from this column all the way down to this last column, and then look at the distance from this last column to the south wall. So you can see it's not all that surprising how it kind of caved in over here when the whole deck collapsed. But then look at this distance from K13.1 all the way over to here. So this is what I was concerned about. Is that too short of a distance? Because see, all of these others here, look how close these are all to each other, from this column to this column to this column. And presumably L11.1 should be right here in the rubble pile, and M11.1 should be right over here inside the pile. But all of these in this area were closer together. So I'm wondering why neither NIST nor WJE have mentioned this. Now here's an aerial view of that column K13.1. So you can see where it was. It was just right at the edge of that planter. And this is where the deck caved down right around it. And there's your trash can right there in the corner. Here's another aerial photo that pretty much shows all of your columns sort of at once, so you can see them here. And the column circled in red is, of course, K13.1. So this one seems to be the column that a lot of engineers are focusing on right now. Now let's see what other structural engineers have to say about this. So after the condo collapse of the Champlain Tower South, the Homeowners Association contracted with WJE, which is Wis, Jenny, Elsner and Associates. They're a prestigious engineering firm that also investigated the Hyatt Regency collapse in 1981. Also known for other collapses like this garage in the 1960s, and even back then, they knew that the problem was spacing of columns and overcrowding of rebar. So why haven't the engineers from Champlain Towers learned from this? Okay, so now take a look at this. So WJE was actually given access to the NIST facility. So here they are in the primary evidence facility taking their measurements. They came to the same conclusion that NIST did in terms of the depth of the rebar being buried into the concrete. And they too discovered that there was excessive cover.
One other thing we just need to point out right away is that even in this core, we're finding excessive cover on the structural slab. And what I'll lead on to later is that this excessive cover can lead to reduced punching shear capacity. The real gist of this is there was a lot of load on this slab that may have not actually been considered by the original engineer.
But if you remember on the video that I showed you last week in the NIST update, they had mentioned that there were certain areas of the pool where there was like 9 inches thick of sand that they put these pavers on top of. And in some areas, they put new sand and new pavers on top of the old, already cemented down, mortared down tiles and pavers that already had their own layer of mortar underneath them. So it just kept getting thicker and thicker and thicker.
It shows at one location in the pool deck, 9 inches of sand in a setting bed was added during a renovation.
And that's what they're saying was not anticipated by the original engineer. How would the original engineers have known that somebody's going to come in 15 years later and add all of this weight onto the pool deck? So here you can see what they were saying was when they built the parking deck, it was designed to be 9.5 inches, but it ended up being about 10.3 inches. And then you can see here what the pool deck had here. You had the structural slab of 9.5 inches. It looks like the original design only had the 9.5 inches for the structural slab and maybe the 2 inches shown on the concrete topping, but they didn't show it in the original plan though. And then here's the tile and mortar, 1.4 inches. And then this was added in 1996. Now, WJE here didn't show all of the layers. It could be they weren't privy to all of the information. Yeah, but in last week's video, I showed you how thick it really was, what NIST found on site. And so the reason why I didn't know about it, you didn't know about it, everybody else didn't know about it before until NIST just mentioned this was because they had sole access to the site, nobody else. So NIST was able to report what they found with that extra amount of weight and sand and mortar and everything else on that deck. On May 22nd, 2022, I did a video on this story that Miami Herald ran. I'll put a link to both of them below for you. But Miami Herald had showed these pictures that they found in the court documents on the class action lawsuit, showing these cracks in this planter here, which is right above column K13.1. And this is what got a lot of people looking more in that direction as well. In my video, I had shown and marked up the photos from the Miami Herald, how the pool slab had sagged and dropped 2 inches. So here's what WJE had to say about it.
And this is a photo taken on June 2nd, 2021. just about 3 weeks before the actual collapse. And this was taken by the engineer that was working on the site, and the property manager had moved this trash can out of the way to show the engineer the distress at this planter. You can see the deflection of the bulb end of the planter and large cracks forming following the deflection of the deck below. This is all likely due to a punching related distress at the slab below. The interesting thing is to note is that a year before, on April 13th, 2020, there was no distress. Punching was slowly progressing around this deck.
I mean, everything seems to be pointing at this K13.1 right now. In this photo here clearly shows what an incredible difference just a year makes and how much damage there was. Champlain Tower South condo was actually collapsing for about a year. WJE also brought in surveyors who mapped out the entire basement floor of the Champlain Tower South condo parking garage, and they only found about a 2.5-inch difference across the entire site. No evidence that any of the columns sank, no evidence that there was any sinking sand, no evidence of anything related to the king tides from the moon either. When you look at these photos I shot right there on the collapse site at the one-year memorial service on June 24th, 2022, you can see the slab was actually in pretty good shape, and there's no evidence that I can see of that any of these columns sank. WJE also came to the same conclusion as NIST, that the rebars were buried into the concrete too deep. There was excessive cover. So this photo here shows that the rebar was 3 inches deep when it was supposed to be 3/4 of an inch deep into the concrete. This gives us lower resistance against punching shear. WJE also made this great diagram that really shows in 3D from underneath exactly that green beam A that you see there, how it sits in relation to everything else, and you can see the complications of that double step down leading from the lobby all the way out to the pool deck just outside Unit 111, which is Sarah Nair's apartment. And so that red column there that's attached to the green beam A would be, for example, M11.1. And when WJE was able to tour the NIST primary evidence facility, they located one of these beam A's, and they got it here in the picture for us.
Item 341, which is a column that we know comes from an exterior wall, and it would have had a beam A framing in. The central core of this column was very much shifted out of center. In plan, the actual reinforcement should have been more like what I'm showing on the left, with the highlighted orange and shaded areas. What that means, though, is that they may not have framed in appropriately. The detailing could have been off, and it made this area even more conducive for the failure that we're about to talk about.
So they're telling us that these BMAs here were likely framed improperly with the rebar, which would lead to making them weaker and not able to support as much load underneath those planters, especially when the problem was exacerbated by the fact that they added all of those palm trees. Now, this is the formula that WJE used to do the design check, and you can see that in the middle there, the VC equals 4 times the square root of FC prime B naught D. So we're going to show you, like it says at the bottom, that coefficient of 4 may be unconservative in this case of low reinforcement. So in recent years, other expert engineers have been challenging that existing formula and opting for the more conservative formula. So now in the last video, NIST did not tell us how they arrived at the fact that the pool deck was inadequately designed, but here they're showing it. So they took all of the dimensions and everything that they measured here at K13.1, and they plugged it into that formula here with the 4 FC prime. Remember, it's supposed to be 3 now, but they used the number 4, which is probably what was used at the time. And even then, the demand to capacity ratio came out to 1.72. This means that the actual demand load right now on the pool deck is bigger than the capacity of that pool deck to handle that load by almost a factor of 2. Same conclusion as NIST. So this is with everything all figured in here. So that was as designed. But then when they looked at everything after the collapse, they said, well, the demand capacity ratio is 0.85. Remember, you want the demand capacity ratio to be comfortably below 1. So you might be thinking, hey, what they measured at the collapse, this should have been okay, but it's not okay. Why is that? Because they didn't use the conservative number here. So let's go take a look at that. So now, if you change the formula to have the 3 in front of it, you can see the demand capacity ratio now climbs up over 1. So now you're at 1.13 at collapse. That's why using the more conservative approach here shows that there was a problem that they didn't see before. So what you're seeing right here on the screen is sort of what NIST was talking about, but they just never mentioned the numbers and showed the difference in the usage of the formula here, like WJE did here. So WJE was saying it was inadequate design of the pool deck, excess weight on the pool deck, the original concrete overlay was not shown on the drawings, the addition of the pavers in 1996 and the large planters in 1996 that were not shown on the drawings, the shallow top reinforcement, and of course the engineers in 2018 failed to identify certain deficiencies. Now, of course, some of the stuff like the shallow embedded rebar could not have been seen by Morabito or anybody in 2018 unless they had really taken a cross-section of a slab somewhere. It also seems like WJE and NIST are aligned in their thinking here on K13.1.
And this distress is consistent with unusually large slab deflections. And in fact, the slab column connection at this line K.13.1 here, by our calculations, had one of the lowest margins of safety against failure in all of the pool deck.
Now, I want to show you something else that both NIST and WJE pointed out here. Now, if you look here at column T on the floor plan, and this is page number 30 out of 336 for those of you playing along at home, when Morabito Consultants, who was the engineering firm brought in 2018, came in to do the 40-year recertification, they wanted to make some modifications along this column line T. So they decided to dig into the floor plan here to check the numbers on these columns to make sure it will support the additional weight that they wanted to put in. There's a porte cochere that comes in here. The driveway comes in off of Collins Avenue right here, turns and goes like this, and then pops right back out. You know, they were going to do some changes to the overhangs, the facade, and everything out front. So he ran these numbers along this column T, and as you can see by this chart here that they showed from WJE, from Morabito's original report, every one of these columns along this line T here has exceeded its loading. So from even what Morabito was showing in his data, it looks like this part of the building even was poorly designed, but this is the part of the building that survived the initial collapse. This is the very part of the building that they did the controlled demolition on July 4th to bring down the rest of this part of the building. Question that I have that everybody else should be wondering now is, okay, if Morabito went in and found mistakes along column T, why didn't he then go and check the whole rest of this schematic here, particularly in these areas that he was doing the other work on, like the slabs, and he was going to have them redesign all of the waterproofing and the pavers and everything up on the slabs, and then on the parking deck over here, the upper level parking deck, why weren't those numbers run? Because they found no evidence of any other calculations being done by Morabito in any of these other areas. And if that's true, this could be an oversight. It's very easy to Monday morning quarterback things like this, but it does look like there was some incomplete work done here. Well, you know, when it comes to engineering root causes, I'm pretty tenacious and I won't give up. And as long as there's more information coming out, I'll relay it to you. So thank you so much for joining us, folks, and we'll see all of you on the next one.